First up, we have Dirk Schulte, who will be talking about the risk of optical distortion by digital printing on glass. I've got a bit of an introduction for you. So, Dirk served as Chief Officer for Vetro, division of Rochman Group. Before joining Rochman, Dirk served as the VP North America Operations at Northglass, VP Sales Engineering at APG International USA, Managing Director of APG's Middle East Operations in the UAE, and earlier Dirk spent a decade as the Global Business Development Manager for Structural Facades at Dormer after graduating as a civil engineer in 1999. So I was about to add 10 years onto you there. But please.
Thank you. So, good morning, everybody. My name is Dirk Schulte. I'm representing Rochman Group. We are specialized facade contractors, and nowadays, in the world of complex architecture, almost every day we are confronted with high expectations from the architectural industry in terms of quality. And when it comes to quality in regards to glass, we typically identify and define quality with optical qualities and optical appearances of glass and glazing in corresponding curtain walls, skylights, and interior glazing as well. So I want to talk about the risk of optical distortion introduced by digital printing on glass. So that's more like a very prestige topic, which talks a little about optical distortion in general, but also bridges to a very specific application, which is digital printing, which more often is being used in modern architecture. So digital printing on glass may enhance the risk of optical distortion on glass. And that's what we will see. We will see what it is, where it comes from, as well as maybe giving some hints and possibilities how to prevent it. So starting with a just generalized cover of what optical distortions are, and after that I will pick two different optical distortion possibilities of how we can see optical distortion on glass, and then bridge to digital printing, as well as talk about a case study. It's not really a case study, it's a project where those specific optical distortions appeared to our surprise, but a surprise always gives a possibility to actually go into an analysis and see what actually happened to create those irregularities in glass. So basically, what is an optical distortion? We all probably know that. So basically, glass is a transparent material, but not really as transparent. Glass has different surfaces, and every time when an incident light beam is going through a glass, is being broken in a different way, we see this as a bend of that light, which is being reflected as an optical distortion. So different optical distortions can be caused by a variety of possibilities, which we all know. We do have bows, warps, pillowing effects. We have roller waves being introduced by the tempering process of glass. We have anisotropies, which are always also introduced by a tempering process while the glass goes through a tempering furnace, is being differently heated up. We have Newton rings and Brewster fringes. We do have low E banding, which is basically a kind of optical distortion introduced by a coating, a low E coating in that case. We do have lensing. We have heard about an optical distortion caused by lensing during a presentation yesterday already, and I will also touch base on lensing a little bit more into details. We have moiré effects, and we have interference banding. So basically, when I am still looking at the optical distortions. We all see this in modern architecture. If we drive through the cities, we do see all the bows and all the pillow effects in insulating glass. We do see the roller waves introduced by to the tempering process in a different way. And all what we see is basically that where the surface of the glass is either being bent or is being distorted by, for example, a roller wave, and marrying two roller wave surfaces then creates a kind of lensing effect where in laminated glass we are bonding two glass surfaces together, and the irregularity of the surface of these different roller waves is then creating that kind of distortion. So going into two different optical distortion phenomena, I would say, starting with lensing. And lensing is quite interesting because we see this all the time somehow, and it's so hard to get this under control. And many times people are asking, well, what this optical distortion is. They see on that glass, they think it is just a roller wave, but it's not. Lensing is basically the interaction and superimposition of the roller waves through a kind of intermedium of bond, like the lamination interlayer. So with viewing it through the glass from inside out, but even also from outside in, we do create different perceptions on the glass surface, which can be varying whether it is the view from inside out or outside in. So that project, for example, when I'm starting with that kind of video, you see that there is a kind of lensing effect which creates a different kind of a reflection of the environment which is outside. And typically that happens in vertical lines, where we see, well, vertical lines, these are not roller waves, but all these different kinds of roller waves are stacking up and creating this kind of double image which you then see through the glass. So next to lensing, there comes this moiré pattern. So moiré pattern is interesting because it's not really a defect in the glass, right? It's more like it's a perception, a visual perception of what we see as an interference pattern, which arises when two similar repetitive structures are overlaid with a slight offset or a misalignment. And this is not necessarily related to glass only. It's like, if you are taking a picture with your electronic camera of a screen, you see a moiré pattern, because you do have this pixelation which overlays above each other, and then you're automatically creating this kind of vary effect. So, and the same happens if we have similar patterns on glass. So we can, for example, print the glass with a surface on surface 2 in an insulating glass, and a surface 4 in insulating glass, having two different patterns which are similar, and approaching that pattern with a view out of different angles, easily I can create a moiré pattern. And again, so it's more like an optical effect rather than a kind of defect in the glass. And it also could happen if you are, approaching a glass which only has a single code of a print, for example, but also, having a kind of, I would say, background picture which has a very similar line or dot pattern, like this one. So this creates a ceramic frit moiré, which I would say, where we do have a glass which has lines printed, horizontal lines printed on that glass, but Unfortunately, and I don't know which building was first. Unfortunately, in the background there is a kind of horizontal line pattern, which creates automatically this kind of moiré effect, which no one wanted. Yeah, it's just like by accident, basically. So it's quite weary. So if you're approaching that glass, or if you're going along that glass, you think like, oh, am I drunken? Because it's so hard and so prestige. If you could take a look at that, it actually creates a real flickering and flimmering effect, which no one wanted. It's not intentionally, right? But it's more like, hey, this is kind of a bad example of how your intention was great. You wanted to have a kind of obscure view with these horizontal lines, and maybe you also wanted to have a kind of sunshine shading effect with these horizontal lines which you have printed onto the glass. But guess what? Unfortunately, there's a building in the background which has very similar lines, which creates automatically this moiré pattern. So optical distortions and bridging to printing. Without any mentioning of optical distortions, what are we doing with printing? So we can print glass, or let's say on glass, with different methodologies. We can screen print, we can digitally print, we can put a coating onto the glass, and typically what we want is we want to create a kind of enhanced performance of the glass. So what are we doing with the enhanced performance? We want to use that as maybe a shading layer, we want to use this as an obscuring layer, and typically what I'm doing is I really want to see something from outside, but not really from inside. So how I'm doing this? I'm doing this with a dual pass print. So a dual pass print is nothing else than a ceramic screen print or a digital print, which works with two different colors. Typically lighter colors, or more like a colorful spectrum of colors, which I can see from outside, and typically a very dark gray or black color, which I can see from inside. So why I'm doing this? So basically, I want either to use that as a shading element or an obscuration element. So I cannot look from outside in, but I can look from inside out. So basically, when I'm printing this with two different colors overlaid, I can, if I'm standing inside of the building, I am able to look outside because the darker color is less perceived by the human eye than compared to a lighter color. So, and using this in modern architecture, again, I'm going to see this more often because architects always want the all-in-one package. So architects typically, I hope we do not have architects here in this audience. I love architects, don't misunderstand me, but we are tending to bundle a package which has too many possibilities, too many tools. But that's also the reason why we have to be careful with all these different technologies which are being given to us these days. So because it can turn out into a great appearance, but it can also go the other way, and even not in all circumstances, but maybe only in different or under different light conditions. So as a practice case, I want to touch base on a project where the architect wanted to have a kind of irregular shaped kind of wheel structure, which is a steel and glass building envelope with irregular shaped glass, which is shaped, which is triangular, which is trapezoidal, which is rectangular, and all in a different pattern. And the upper part of that veil needed to get a kind of solar shading in order to shade the interior of that building. So what the intention is we wanted to use a dual color print in order to let the shading actually perform from outside with a lighter color, but not being visible from inside out with a darker color. So unfortunately, with irregular shaped glass, there is always a difficult approach when it comes to glass fabrication. So how can I push the glass through the tempering furnace? In which direction? Is that the same direction I am printing the glass and pushing it through a printer? In this particular case, the architect wanted to go into the nitty-gritties and wanted to have a very small pattern with a high density of dots. So we used a dot frit matrix in this particular case in order to really create a kind of fabric-like pattern, which was almost invisible, but going into the smaller layouts always creates another problem. So basically what we have here is a heavy glass, laminated outside, laminated inside, insulating glass, outside 2 times 8 millimeter with a low E coating on surface number 4 and a dual frit pattern digitally printed on surface number 2. We do have a thicker glass at the inboard light, 2 times 12 millimeter, just due to the fact that we do have large spans, different kinds of geometries of panels, which all comes together and may create a problem. So when we take a look at the dot pattern, we do have the minimalized dot diameter of 1.8 millimeter, 1/16 of an inch, so small in a center-to-center distance of 4 millimeter. And when you're approaching a glass fabricator with something like that, he will say, oh, you know what? This 1.8 millimeter dot, go to hell, we'll start at 3 millimeter, right? So in this particular case, we really turned it over and said, well, can you do that? Well, we shouldn't have done that. So of course, the glass appearance looks like that. Not all the time, but in some conditions. So it creates a kind of, and I hope you can see that, creates a kind of moiré effect with an interference banding. So you see this banding, this is not intentional. So it's not like we wanted to frit bands on the glass, but it's more like an interference perception. So there are panels which create this moiré effect. And we were wondering why. Because we only have one layer of that layout, right? So it's not like we do have 2 different similar patterns which are, slightly offset. And here, another picture of that kind of interference banding. So again, not intentional. So the typical appearance of these bends and the moiré patterns were mostly visible under not direct sunlight, but overcast light conditions and without interior lighting. And mostly in degrees of 90 to 65 from a viewing perspective point of view. So how is that caused? We were, scratching our heads and we're thinking of, it can't be, because it's only one layout, one pattern, what we have. So we actually found out that there is a tolerance in printing. Guess what? Every printer has a tolerance. So how everything has been printed was that we have had a larger dot, which was light gray, and a smaller dot, which was dark gray, in order to make sure that you don't see the dark dots from outside, but more like the dark dots from inside. And that's all good. If everything is centered in, like the case A, concentric, it is all good because it really creates a kind of regular pattern. But due to the tolerance the printer has, it could also be offset, kind of case B and case C. It could actually even also push over the edge of the white dot, which creates a kind of offset between 2 different patterns. And that's what we saw. This is case A, view from inside. This is case B. And just this slight offset creates a kind of visual banding, which is not intentionally, but visually perceivable on the glass. And case C is where the dot is actually further away and overlapping the white dot, which even also creates a more intense perception of that kind of bending. So what does it tell us? It tells us that we all need to factor in all kinds of different possibilities, what can go into the wrong direction. I wouldn't say that's a wrong direction, but it's more like it's not visible through a direct sunlight. And it wasn't visible during the 100% inspection we did in the factory. And it wasn't, surprisingly, it wasn't visible during a visual mock-up. Yeah, I mean, we are professional people. We do visual mock-ups. We do, benchmark glass mock-ups at the glass factory in order to make sure that everyone understands the quality which is being fabricated. And everyone understands, how that glass, creates a benchmark for a quality which is being fabricated onto the building. So only once the glass was at the building with all these conditions and the light and the reflective wall in the background, it was visible, and even not all the time. It was more visible, during, various times over the day and only under different light conditions. So as a conclusion, the observation and the analysis was telling us that we should take a consideration on atypical shaped glass, because that always creates a kind of risk where an optical distortion may appear. Different shaped atypical glass units in combination with static digital print directions. Dot on dot is something which is critical, not as critical if you do have a larger pattern, but it's becoming more and more critical if you do have a more denser pattern with small little dimensional lines and dots. Micro offsets between dots and dot locations caused by corresponding tolerances. Lensing and reflections of dots, offsets through multiple glass surfaces. If you have a multiple glass surface, if you have a multiple insulating glass with different glass surfaces, different thicknesses of those glass surfaces is just enhancing this kind of optical distortion. And when it comes to digital printing, we do have another problem where we do actually have slightly scattered frit registrations around the lines of the dots. So all that combined can create that kind of appearance of an optical distortion. So the path forward, and it's also a good picture what tells you, how you actually need to take care of the pattern, the layout, and the dimensions. So the left picture shows a slight banding effect where you do have a more denser pattern, and the right picture shows a clear glass where you do have a larger pattern. So basically, and going through all the standards and regulations for printing, not necessarily digital printing, but printing at all, there are very few standards which are providing guidance, and that's what we want to work on. We want to work on, creating this kind of guidance. We want to work on future regulations to be developed based on minimum pattern dimensions in comparison to the size, formats, and makeups. That's something what we need to step on, and I guess we can all collaborate in that. There is a task group already in place at the NGA, the National Glass Association of North America, which deals with digital printing guidelines, and we also want to get this into place. Further, I need to get some credits spoken out to SDH, Bureau Happold, Gilbane Construction Company, Glassbell, and Contravision, which all helped to get this together. And it should not, be a kind of warning. It should only be a guideline of what can happen and what needs to be done in terms of creating a fully bundled package where we always need to be aware about the consequences. Thank you very much.